Thanks, Megan. Yeah, as Megan mentioned, I'm with KBR, contractor to USGS Aeros here in Sioux Falls. I have been on the LANDFIRE team for, can you all hear me? I just want to make sure before I keep going.
Yeah, sound
Yes,
great.
we got you. You
Okay,
sound good.
very
Thanks,
good.
Daryn.
I've been with LANDFIRE for 6 years now. It's been a lot of fun. It's gone really fast and primarily involved with the vegetation piece. So I put together some slides today to just kind of cover the highlights and give people a little taste of how we make the vegetation products, some of the ties to the other products, and then, yeah, as Megan mentioned, about 15 to 20 minutes with leaving, time towards the end for questions, discussion, comments, anything like that. All right, so here's an outline of what I thought would be good to cover today. A little intro to LANDFIRE, cover our three main vegetation products, EVC, EVH, EVT, also touch on life form, and really looking at the mapping methods today. I wanted to touch on some of the masks that we use because that's important for users who are trying to figure out how to use the data and the products. Look at what we do for our updates, and then a little sneak peek into what we are working on for the future with the image-based update prototype. All right, just a little brief introduction on LANDFIRE. We are both land and fire, so not just fire, and funded by the Department of Interior and Forest Service with other partners listed down here at the bottom. We are all lands, meaning CONUS, Alaska, Hawaii, Puerto Rico, and other insular areas. This slide shows all the various products that we provide. So nearly 30 products in the realm of reference, disturbance, vegetation, fuel, and fire regime. There's some arrows here, yeah. So today we're going to be looking at our existing vegetation products. We also have biophysical settings, which is pre-European conditions under vegetation. And, all these are interconnected. We use the reference information and disturbance in the mapping. And then the vegetation is primarily used for to create the fuel model products, and then also the fire regime products. So that's where it kind of fits in the big picture of LANDFIRE. And if you're interested in some of these other products, definitely check those out, but we're going to be focused on the vegetation piece today. I wanted to give a little history of LANDFIRE and where we're at. We started off with version 1.0, that was, the maps were circa 2001, representing those conditions. Those were our initial base maps. So we modeled all 30-meter pixels using satellite imagery, field training plots, classification trees, the whole 9 yards. That was subsequently updated over the next 15 years with transition rule sets. So no imagery or modeling involved, but basically just saying if there's this type of disturbance, we're gonna just change those pixels based on these rules, informed by expert opinion. Our second base map was, we call remap, and that was LANDFIRE 2016, where we again modeled all 30-meter pixels and lots of improved technologies and methods for doing that. It's a huge effort and a great success. We have updated that subsequently for LF 2020, and we're in the progress of producing LF 2022. Here it shows some of the different boundaries that I'm going to be referencing. For EVT, we model within Almernic or EPA level 3 ecoregions. Those are grouped into 13 what we call vegetation production units on the top right. That's within which we model life form, cover, and height. So the structure, those are larger models. That is then fed into fuels, which is processed by map zone, something you might be familiar with. This is what NLCD uses, what LANDFIRE has used in the past. And then for distribution, those map zones are grouped into 6 GeoAreas across CONUS. I have a banner at the top of my screen, but I'm hoping you guys don't see that.
No, we see your slides.
Okay, very good. All right, here's a slide showing the methods of EVC and EVH, so existing vegetation cover and height. Starting with remap, it is continuous output. So for cover, it's 10 to 100%. And then for height, herbaceous and shrub are a centimeter, and then trees are meters. We build regression trees using the cubist algorithm that has worked well in the past and continues to perform well for us. Like I mentioned, we model each VPU, those 13 across CONUS. So that's where we're creating these models and applying them. What we're using for predictors or independent variables is primarily Landsat image composites. So we have one for each season. And then we also have an NDVI composite over 5 years, giving us some metrics on NDVI, maximum, minimum, median. And then the models are trained by the plots in our LANDFIRE reference database. For tree cover, we primarily use the FIA stem map plots. It's a specific method for deriving tree cover using basal area within those FIA plots. For tree height, we use all plots in the LFRDB. Same for herbaceous and shrub cover and height. For tree cover, starting with remap, we did incorporate LiDAR, process that to a grid to train the models as well. Basically taking all first returns within that point cloud above 3 meters, dividing it by all first returns. And so that is a crude way to get cover, but it's very, if anyone is familiar with LiDAR, it's very dense and very good data. So it did work, it did improve and help the models quite a bit, to the point where really the LiDAR is driving the tree cover and height models. For tree height, we use the 95th percentile of that point cloud. And we also used information from NLCD fractional veg to help train the shrub models. We're continuing to look into that. Now that piece of LANDFIRE, or now that piece of NLCD is called RC map, rangeland condition map assessment projection. And then so that's how we model all the natural vegetation. And then we mask out, things like agriculture, developed roads, water, ice, snow. We also identify barren and sparse vegetation. So that's less than 10% veg, using NDVI thresholds. And this is all informed and separated to tree, shrub, and herb using a different modeling process, which I'll mention later. So that's a highlight overview of EVC and EVH.
Before you move on, Daryn, Louis had a quick question about the LiDAR. Was that only for a few areas, or was that?
Yeah, so we got all the LiDAR we could across the country. And so we only needed, for a given VPU, we only needed maybe 50, LiDAR samples or, paths where they're flying the LiDAR. And so that is enough to train the models within those VPUs. So we did use it across the country. Does that answer the question?
Yes.
Okay.
I didn't know how you could afford it, so someone else paid for it.
Yeah, this was all publicly available LiDAR from, at the time it was available on Earth Explorer. But now, there's different warehouses that provide it. So yeah, nothing that we have privately. But every year, more and more LiDAR is being flown and made available. And we plan to continue to use it as much as we can. Here's the flow chart for EVC, and EVH is next, and it's pretty similar, but just kind of saying the same thing, but in a different way. We start with LFRDB or LiDAR, and then the predictive variables that all goes into building and running that model. We model herbaceous shrub and tree cover all separately, and then that comes together with that life form mask that I mentioned. So we're not deriving what's tree, shrub, or herb from the cover models. That's actually a separate thematic classification tree model. Those masks that I mentioned come into play as well. Agriculture developed, Barren, and then disturbed areas are identified with our LANDFIRE annual disturbance products that are combined into what we call historic disturbance, or HDIST. And that's what is used to create FDIST, or fuels disturbance, what's used by fuels to identify disturbances as well, so that all syncs up. And then for cover at the end, we do a percentile cap using EVT, so that so by each EVT, the cover is capped, and so it makes sense for that EVT. So you don't have really high covers for EVTs where it doesn't make sense. That is EVC, and then EVH, basically the same thing. All right, and moving on to existing vegetation type. So for remap, we used the ecological systems and produced a map based on that classification system, similar to what's been done in the past. We made a second EVT based on the NVC system, the National Vegetation Classification System, and those were the group level of the hierarchy. But the fuels continue to be produced based on that ecological systems EVT map. So for the model, instead of a regression tree, we used a classification tree. Again, the C5 algorithm has been used in the past, continues to perform well for us. We looked at some other CART models like random forest and others during the planning for remap, and found that what we've been using still works just as well or better than some of the newer algorithms. And I think just has to do with the type and nature and amount of the data that we are using to inform these models. They're fairly simple models. The boundaries are the EPA level 3 ecoregions. And the predictive variables are similar to what we use for structure, the Landsat imagery. We also put in topography, elevation, aspect, slope, and then some climate variables, because that's really important for separating the different vegetation types. And then the training data are the field plots from the LFRDB, and those are labeled to the ecological system or NVC group using an AutoKey process, which is basically a set of sequence tables that puts the species cover for each plot through this list of rules. And if any of those are met for that plot, then it's labeled with that given classification type. And then other plots are manual that don't have enough information for those AutoKeys. They require, species cover information, but sometimes a lot of plots don't have exact information in the format for those AutoKeys. And so hundreds of thousands of plots were also manually crosswalked by NatureServe. So a lot of work goes into labeling each of the plots to the type for us to use in the modeling process. So for the masks that are used in this process as well, we have that same life form mask that I mentioned that separates the tree, shrub, and herb. We also have a riparian and wetland mask. We use that same barren sparse mask that's used for cover and height. We have developed rural vegetation that's identified using wildland urban interface for remap. Now we have transitioned to using building footprints, which is a lot more detailed, specific, and a lot better for identifying that developed rural vegetation or developed vegetation in and around more the impervious structures. We do identify recently disturbed vegetation in the remap products. We have moved away from that. So now, the recently disturbed vegetation is just going to go to whatever vegetation type it's closest to. Here's the flow chart. Similar to what you saw before. Again, we add in the precip and temp variables, the topographic variables, the same Landsat imagery. We have a QC filtering process on those LFRDB plots as they come into being used in the model. We model each of the herb types together, shrub types and tree types, those all get modeled together. And then the sparse types get modeled together so that when we put it back together, it matches that life form mask and it matches the cover and height products as well. And in the end, like I mentioned, we had the EVT based on ES and then also a second on NBCS. Here is just showing how we have our type, cover, and height all use that life form mask. So they nest by life form. As you can see, all the pixels that are a tree EVT are also tree cover and tree height. Same for herbaceous and shrub. So that it makes sense for each pixel and we're able to assign fuel models that way. So we are not yet, but in the future, we would love to be able to provide, like for the tree pixels, provide the shrub and herb cover and height. And that's something we hope to do in the future. But right now, it's mutually exclusive in that if it's tree, we don't have any information on the shrub or herb in between the trees if it's an open canopy or underneath the tree canopy if it's closed. We do an agreement assessment for EVT, and that information is available along with the data. Here's just an example. For each type, we're going to have, hold out 10% of the training plots were held out if there was a sufficient number of plots, and then that's used to give us a performance metric, an agreement. So, how many of the plots of those withheld validation plots agreed with the type. So we're modeling hundreds of different types of vegetation. And some of the agreement is surprisingly high, some of it's surprisingly low. And so we provide, what are the types it's getting confused with. And oftentimes it's very similar types where you could see how that confusion could occur. But we want to provide that information to help users be informed of, how it did in this agreement assessment. Here's a list of the masks that I mentioned somewhat already, but I did want to just highlight or provide them in a list here and talk about them specifically. So for identifying developed areas, we primarily use NLCD, what they identify through their impervious cover mapping process. We also use roads from them. And then, like I mentioned, we are not using building footprints from, those are originally from Microsoft, and then USGS has rasterized that, and we use thresholds to identify additional developed areas. For agriculture, we use the NAS CDL, cropland data layer, and then NLCD pasture hay as in addition to that. So that developed an agriculture mask is updated for each, a new version of LANDFIRE that comes out. So we're going to be using the latest and greatest for the next update, LF22, that's coming out. Water, barren, sparse, and snow and ice do match as well between the vegetation products. And I was going to talk a little bit about the water mask for barren sparse. As I mentioned, that's NDVI threshold. And then snow and ice we take from NLCD. We also make a riparian wetland mask for the EVTs that are riparian or wetland, and then an alpine mask as well. So those are not going to match between the products, but they're going to be important for making sure that those specific EVTs are restricted to those zones where they should be. So we did put quite a bit of work into identifying open water for remap. We used the dynamic surface water extent outputs, and then also NHD streams. So it's a good water mask. We do want to keep it updated, but right now it's going to be representing circa 2016 conditions. That riparian mask as well, quite a bit of work goes into that. We take known locations of riparian and wetland veg, create a regression tree model, match that up with the topography to give us that final riparian wetland mask. So that concludes some of the methods that were used for remap for that new base set of products. I did want to touch on what we do for updates. I mentioned before, those are transition rule sets. But basically what we do is take our base map and the disturbance information, and based on the severity, the timing of that disturbance, and the type of disturbance, we've got hundreds of thousands of rules where each of those combinations occur. The vegetation as a cover and height are adjusted. So for example, if there was a high severity fire, the trees are going to transition to herbaceous vegetation, and then over time shrub, and eventually back to tree. So that's what's going on there. And what we want to do is move towards using more imagery in our updates. So not waiting another 15 years to use imagery and machine learning again, but somehow build that into the update process where we can to improve on the rule sets that we're using. So more, better, faster, of course. We want to reduce the latency of our updates and increase the frequency. So more of them and representing ideally conditions for the year prior. And this figure just shows that idea. So in remap, where we had a high severity fire and it was all herbaceous, using more recent imagery to model what's there, and then update the maps with those modeled results instead of just a heuristic transition rule set. So accounting for recovery and then new disturbances. That's all I had. So
awesome, Daryn. Thank you. We've had a bunch of questions come in. Some of them
okay.
have been answered by Inga. Some of them have been answered by Randy. I was wondering if Chris Mersu, you might want to unmute yourself and ask the question. If you don't want to do that, I'm happy to read it, but it's always better when the person asking the question can interpret or say it.
Sure, yeah. I think I'm unmuted. Can you hear me?
Yeah, Chris, tell us where you're from, and that would be awesome what you do.
Yeah, U.S. Fish and Wildlife Service. I'm a regional fire planner. So maybe this is more of a topic for a future call, but I think the answer to my question is to customize our LANDFIRE map to address fire behavior in wetland fields. But he mentioned using a similar type process for wetland vegetation, riparian vegetation, or just emergent vegetation as what's used in a Barren mask. And it piqued my interest if some of the wetland vegetation is masked out in some of this to show a certain way, similar to Barren, then how does that follow through as a product to be used in something like FSIM if you're trying to model fire spread and potential values at risk and that kind of thing. So maybe I'm off base. Maybe I missed the point that was being made, but that was kind of where I was going with this. So in drought situations, obviously emergent vegetation is now receptive to fire. So
yeah, it's probably my fault in using the word mask, but that's basically just to get the vegetation right. So we do care a lot about getting the riparian and wetland vegetation types in the right spot. And that's what that mask helps us do, because we can't just really model all the vegetation types together. We have to separate them out and use these masks to get them to land in the right spot. So the fuels does use, does assign fuel models for those riparian and wetland areas. And then it's a different mask and a different process for identifying the Barren. And that is going to be less than 10% veg. So Barren is 0% veg, and then sparse has some vegetation, but so 1 to 9% in a sense.
Okay. So it's not quite the same as Barren, but it does adjust things more for getting the classification right versus any outputs for fire behavior, is what you're saying.
Right. Yeah. Because if we can't model the sparse and riparian and other types together because they wouldn't always land where we want. So that's why we use NDVI to identify those barren areas. And yeah, so the 0% is going to be non-burn, but then, 1 to 9 sparse is going to be burnable some years, if there's rain certain time of the year.
If I could just add, Chris, I think this might be relevant to your question. LANDFIRE does produce seasonally adjusted fuel models. They're called ModFIS, and I could put a link to that, and that helps with some of that seasonal drought.
Great, thanks.
I'm not sure it addresses drought in wetlands, though. it's more of a rangeland type thing. I mean, that is definitely what, I think an area for improvement in LANDFIRE is those areas of wetlands that do dry out sometimes. And I'm not sure that's something that we've really accounted for yet.
Well, that's what the Southeast ModFIS is all about, basically, is wetland areas that when the water table drops there and exposes more fuels, particularly in the swamp areas, that's what we tried to identify with KBDI down in the Southeast.
Okay, so it's in the works.
I was just scrolling back up to the top. Peter had a question about regen. Peter, did you want to unmute yourself and ask it and tell us what you do and where you're from and provide a little more context? Or Peter asked, where does regen fit into the LiDAR classes?
Yeah, so I'll throw two things in one. LiDAR, yeah, we're using it more and more, including on drones now. I'm from state of Colorado. I work for the State Forest Service here, but you know, we're looking at how do we characterize that understory that's growing back up, and is LiDAR going to be that finite or highly resolution enough that we can use it at a national scale? That's coming along, and I'm really excited about the use of LiDAR. The other thing is, and I'm just going to make a comment, is that as far as fire modeling and fire behavior, you know, how do we register regen, because it changes the fuel model completely. It goes from a canopy model to potentially a shrub and other fuel model. But Scott and Bergen, last comment, and then I'll be quiet. You know, they do have the ability to condition the fuels over a season, and I think that's there's some tools in LANDFIRE that are helping to do that. But I think that's really important, especially with riparian models, where riparian goes from it's wet to no, it's completely burnable, and it's at the bottom of the slope, and it can fire off a whole landscape. So just wondering how often that layer might be conditioned using more localized weather, but that's probably more a regional and local function than it would be for LANDFIRE to tackle. I'm done. Listen to good bluegrass music.
Peter, Randy Swati here with the Nature Conservancy, and I think that I know I see Robert Zeals here from the Great Lakes as well, and he's shown me situations where we have balsam fir coming up under aspens, for example, and that's a huge concern for fire managers in some places in the Great Lakes. And I'm thinking that what you bring up might be similar to that example as well.
Well,
so that there
in the Southeast, you did specify some like the plantation areas, right, Daryn?
Yep, those are a class. Yeah, and that. Yep. Mm-hmm. Henry, I see your hand up. Are you thinking of an answer on this one? Because I still think we're looking for more information on how LiDAR might get it under and mid-story vegetation that could be of interest to fire managers.
Yeah, so what I was just going to comment, I think Peter's bringing up some really valid points. And based on, he's exactly right relative to the Scott and Bergen 40, there's only so much you can do, right? they are a model, and they do not do a good job of characterizing and parameterizing the entire landscape. And so the things that Peter's talking about, there are limitations, and then within those, you do need to look at conditioning the fuels and things like that to help refine what you're seeing relative to fire activity, spread, flame lengths, etc. So I think the key thing that I would say, Peter, to your comments are, yep, they're right on. It's acknowledged. There's actually a number of things that are occurring in, I'll call it the science arena right now, particularly with some things like 3D fuels, Hudak, Parsons, etc. We're looking at that. And with what Daryn just talked about with LiDAR, we're hopeful that we'll be able to leverage, more detailed information like that to help us do a better job of, mapping fuels, both from a canopy as well as a surface fuel, structure in the future. But that's going to take some additional time, work and effort to, get there. So, right now, we've had the 13, then we got the 40. And so that was, a step in what I would call a future, progress. But I think there will be new things that will be coming on the horizon to, get at what you're talking about here, because you can only do so much, with the 40 fuels. So I don't know if that fully helps, Peter, address or, get to your question, but I will say there's more to come. It will involve a large, body of folks. A number of researchers are currently dabbling in this, and then, we'll have to do some coordinated work to get there. So I'll stop there.
Thanks, Henry. No, I appreciate it. Yeah, I know it's evolution. So just trying to use all the really great stuff that's already out there. And it's going to come down to the local, I think, folks who are going to have to modify their local behavior based on what information they have and what tools they have. So no, it's all good. It's really all good. And thank you so much for all your effort. But it comes down to boots on the ground, figuring out how do we tweak what we have to work with. So I think it's great. Thank you.
Oh, you're welcome. And you're hitting the nail on the head, because, as great as LANDFIRE out of the box is, we acknowledge and recognize that people are going to have to do, as you say, tweaks. Any good F-band L10 is going to take some time to work through that process and tweak things. So you're spot on there, Peter. But good comments, in general, because I do think we're, with the technology and what Daryn was able to talk about, some of the vegetation mapping methods, we've got a lot of nice pieces that are coming together that can help us, think about, future ways to do a better job, with mapping these things.
Well, thanks. I've been working with this data set since 2004. And so I really appreciate the effort and the science and the deep thought that's going into this. But it's all, as my saw partner on Arrowhead Hotshots used to say, it's not the tool, it's the nut loose behind the handle. So thank you so much for all your effort.
Right on. I appreciate that last comment. That's excellent.
Charlie, did you have something to add? Or Tobin? Okay, go for it.
Oh, if Charlie wants to add, I'm more than happy to let him add. I was just going to say, with the 40 fuel models, conditioning will only get you so far. You're right on that. It's whatever you can get from your raws, and then your model does all of the conditioning for your fuel model. And so if that's not getting there, you have to look at changing the fuel model. And that's something that we do in the Southeast ModFIS, is we actually do change the fuel model based on the drought index. So once again, we're looking at ModFIS for something like that, but that only pertains to the Southeast. So yeah, you're right on things. You have to change your fuel model, and then whatever, based on maybe another index system that you're using, can help you out with that. Did you have something to add, Charlie?
Yeah, I was just gonna speak to the part of the question that has to do with timing, because some of these areas, and we run into this a lot in LANDFIRE, a lot of the areas that they want a descriptor for real active fire behavior only reach that condition for such a short period of time during the year. So, you know, what we tend to do is try and identify a fuel model that's fairly close to what they would burn like if they were totally dry for, you know, if they were, let's say, a wetland that was totally dry for maybe a 2 to 3 week period out of the year, only at you know, on certain years, we try and address the fuel model as best we can towards that indicator of the fire behavior that would occur if that area was dry. So it is up to the local expert to be able to dial that down for all the other parts of the year. And you know, it's always a question, and we keep running into that with agriculture in particular. You know, there's a certain period of time where wheat fields are very volatile, close to harvest, and to be able to address that, I mean, on a static map where you tend to have the same field model for the full year before the update is completed. It takes some thought to try and get a field model that people can work with on the wet end as well as the dry end.
Thanks, Charlie. Daryn, can you see Kayana's question in the chat window? I don't know if Kayana, you want to unmute yourself and ask it, or I'm happy to read it as well.
About GTAC. We're familiar.
Yeah, I don't know what GTAC is, so maybe you can.
Yeah, we're familiar with their work, but we're not collaborating with them directly right now. But yeah, if sounds like they're trying to do the same thing as us, so we'll definitely be privy to that and see if we can get
Kayana, where I can see you unmuted yourself. Tell us about what you do and where you're from.
Yeah, hi. I'm doing a very different role than I was 2 months ago, but my role 2 months ago was working as a forest health monitoring coordinator in Forest Service Region 5, which is California and West. And so, yeah, I mean, there's a big push to figure out how to use more remote sensing in forest health monitoring. And I think that, but in that world, there's not a lot of use of LANDFIRE as there is in, you know, fuels modeling, for example. But I think that it sounds like there's a lot of room for collaboration, especially with how robust your data set is and how you're using LiDAR. For example, one of the things that I had done when I was in my role is the state of California is working on getting a bunch of statewide LiDAR, and they were asking us about what kind of derivatives would have been useful or would be useful. And it would have been great to have had your contact information to ask what derivatives would have been useful for you guys. And it may not be too late. So anyway, I can send my email, or I can reply to Megan's email with my email in case you're interested in being put in touch with some of those folks.
Yes, yeah, please
definitely.
do.
Mm-hmm.
Yeah.
The left arm and the right arm. Sometimes it's nice when they're coordinated.
Yeah, for sure. I mean, we're going with the lowest hanging fruit for LiDAR. It's, you know, nationwide data sets. You know, our first stop is what USGS has. But there's a lot more available by the states that, you know, if we can get a way to, you know, manage all of that, we would love to, because it's surprisingly not a lot available from these nationwide warehouses, so to speak. A lot of it is at the state level still, and even private.
I'll speak for Colorado. After the 2013 floods in September, FEMA flew pretty much the whole Front Range of Colorado, going up into the hills. And so, yeah, so there's data sets like that are on the national map, actually. But yeah, you're right. I know the work is going forward to get more LiDAR data, and that gives us forest structure, disturbance impacts, and just general higher resolution information. But who's going to house that? Maybe the national map, instead of putting the burden on you guys. But it's out there and it's accumulating. So.
Thanks, Peter. Louis, did you have something to add? Go for it.
Yes, the comment about the vegetation height, I know that it already is mapped by 0.5 meter increments, but since Daryn mentioning that there was maybe an interest in mapping this under the canopy, I assume that there may be new methods or something different that's going to be done in the future and be contemplated. And if you are going to do that, just a general comment that some of you work in rangelands or know is that there's many different ecological systems of shrublands that exist within that first 0.5 meter. Wyoming sagebrush is in there, but black and low sagebrush are also in there. So 0.5 meter increments for understory is just either in a canopy, forested canopy, or in rangeland is not good enough. If you're going to do height, it needs to really be finer than that. Even 0.25 meters would make a big difference too, because then you could separate all sorts of things. Also, you could separate, if you ever get into the canopies, I don't know how you're going to do that without LiDAR, but it's, the different in aspen stands, which are expansive in the Rocky Mountains, the difference between having no understory in aspen stands and having a robust understory is a definition of depleted versus healthy aspen. So if this question is done somewhere, then I would like to know, if it's done again, if you guys go down that road, just consider that when it comes to shrubs, we really need finer resolution than 0.5 meter increments.
Yeah, you might be thinking about prior to remap. Remap, we started doing 10 centimeters. For the herbaceous and shrub height.
Oh, okay. Well, I've never this is where I'm.
But getting that accurate is tricky.
Okay.
And we tried using LiDAR for that, but it is very difficult, as you could imagine, especially with those low shrubs. Because LiDAR doesn't know if it's shrub or herbaceous or rock.
Yeah, I think that's boots on the ground, probably drone-based, localized data collection at this point, if that's that much of a concern. But it's moving forward in that direction. So that could be fed back up to you guys.
Henry, did you have something to add? I wasn't sure if I saw your hand up or if I was imagining that.
I was just going to go back to Kiana really quickly, to her point about tying back in with GTAC. So we do, we're tied in with them through the Forest Service and their tree canopy cover product that comes through the Multi-Resolution Land Consortium. So there's a piece there, but then there's also, just as Daryn talked about, her key point is LiDAR, and through the various, national repositories where things are, we're trying to, connect to those, areas as well. So I think it's a good point that Kiana's making, that there's a lot of opportunities to coordinate and collaborate, and, there's many other players in this space, and we just need to make sure that as we're working in this space, we don't go it alone. Kind of then gets to, Kyle's comment here about JEDI, same thing. I'll quickly just, jump on that one. We do have a postdoc through University of Maryland working with LANDFIRE right now to look at JEDI data. So there is more to come on that piece as well. And I'll just stop there. There's others that may want to add more to that, but that's just a quick one.
Thanks, Henry. We still have a few minutes left if anyone wants to ask any final questions. Go ahead, April.
Hey, how's it going? I just had a little bit of a off-topic question, but more of an open office hours question. I've been diving in a little bit with the 2020 fuel rules that have been a bit updated for the new release, and I had sent this question in and just thought maybe it'd be helpful to have others share a little bit of an answer too. But I know with the new 2020 release, there's the 700 series of disturbances that has been added in, that has been designated for kind of like unknown mechanical add disturbances. And so this is maybe a question a little bit more for Charlie or Tobin. But I was just wondering if someone could kind of give a little bit of a broad overview, high level overview of like, there's the 200 and 300 series, which represent these are FDIS codes. The field disturbance codes. So the 200 series, my understanding is those are mechanical add disturbances, and then the 700 is unknown mechanical add, and then the 300 is mechanical remove, and the 600 is unknown mechanical remove. And so I'm just curious, there are these two different sets that exist, and kind of what's the goal or intent behind having those?
I imagine Henry or Charlie's waiting for me to answer this, so I'll go ahead and go for it, April. It's good to hear from you.
He unmuted himself, so maybe you should just make him do it.
Yeah, well, I'll start and he can close it. How about that? So the 700 series is actually mastication. It used to be part of the 300 or 200, which is mechanical add. We broke it out because it's actually it was something that we could specifically break out from that mechanical add grouping. So 700 is specifically mastication.
Okay, so with that intent, 200 series could now represent mechanical add, not including mastication, and mastication is better slotted under the 700 series.
Correct. Yep.
Is
so
there
the mechanical add has that's more of the lop and scatter, pile burning, that kind of thing, or piling, not necessarily the burning part. Did you want to add to that, Charlie?
No, that pretty well covers it. There are a few stipulations in the mechanical or in the mastication 700 series that you might want to take into consideration, since all we're addressing is mastication that puts the material back on the ground. We don't have the information to say if the mastication was for commercial purpose and hauled off as of right now. We don't get that from the LFRDB. So basically everything that we're addressing in the 700 series is chips that are put back on the ground. And that's why you'll see a lot of timber litter models in that 700 series. Great.
Okay. Thank you very much for that. And so then between the 300 and the 600 series, is there a similar thought there, or is the 600 more of a designation of maybe like disturbance source?
Yeah. So the 600s are, we call them mechanical unknown, right? So we treat them as a mechanical remove. So they get the same rules as the 300 series. Yep. Awesome. It's just they're labeled as mechanical unknown because they've been identified as disturbances, and they are in the FDIS, right? But we don't have enough information in there to say what the type of disturbance was. But the majority of them tend to be a mechanical remove. So we just treat them all as mechanical remove to catch the majority of them.
Okay, that makes sense. Because like in the HDIST, it might come through as not having an event, but seeing change detection. And so there's
exactly.
A little bit of... Okay.
Yep.
Great.
You're right on.
Thank you very much.